Failure is success if we learn from it. Hi students, in this video we'll go through additional problems from exercise 1.1, problems from 12 to 16 related to types of relations. Also, you can join the Telegram group for further updates and notifications on videos. The link is given in the description box. So we will go through this 12th problem. Show that the relation R defined in the set A of all triangles is defined as T1 is similar to T2. So if you have two triangles T1 and T2, they should be similar to each other. That is the relation. We'll have to prove that this is equivalence relation. So the set will have all kinds of triangles with different sizes. Now how do you say that one triangle is similar to the other triangle? If the ratio of the sides of one triangle is same to the ratio of the sides of the other triangle, right? So if the ratio of sides of this triangle is same as ratio of sides of this triangle, only then we say it's similar. So R will have similar triangles. All similar triangles would be there in relation R. Now we will have to prove that it is equivalence. It has to be reflexive, symmetric and transitive. So we'll first check reflexive case. Is it reflexive? For reflexive, what should it be? A comma A should belong to R. That is T1 comma T1. If you have triangle say T1 and T1, it should belong to R. Here the relationship is similar. Two triangles should be similar, right? Every triangle is similar to itself. So I can say R is reflexive as every triangle, right? As every triangle is similar to itself, you can say R is reflexive. Next, symmetric. So what is the condition for symmetric? If A comma B belongs to R, this implies that B comma A belongs to R. This says that if we have two triangles T1 and T2, if both are similar, it implies that T2 comma T1 is also similar. Now obviously, right, if T1 is similar to T2, then T2 is similar to T1. So the reverse combination is also true. So you should say this as R is symmetric as T1 is similar to T2 implies that T2 is similar to T1. For transitive, what is the condition? If XY belongs to R, YZ belongs to R, then XZ should belong to R. Now here we have triangles. If T1 is similar to T2 and T2 is similar to T3, then T1 is similar to T3. So you will say T1 and T2 and then T2 and T3 implies that T1 and T3 belong to R. Now this is obvious, right? So if T1 is similar to T2 and T2 is similar to T3, then T1 is similar to T3 because all three triangles will be similar. Therefore, we can say it is transitive. So we'll say R is transitive as T1 is similar to T2 and T2 is similar to T3 implies that T1 is similar to T3. You can also write it as T1 comma T2 belongs to R, T2 comma T3 belongs to R implies that T1 comma T3 also belongs to R. Now since the relation is reflexive, symmetric and transitive, we call it as equivalence relation. Now let's go to the second part of the question. Consider three right angle triangles T1 with sides 3, 4, 5, triangle 2 with sides 5, 12, 13, triangle 3 with sides 6, 8, 10. Which triangle among T1, T2 and T3 are related? So triangle 1 has sides 3, 4, 5, triangle 2 has sides 5, 12, 13 and triangle 3 has sides 6, 8, 10. Now which triangle, whether it is T1, T2 and T3, which are related, right? Which are related. Related means, what's the relation here? Relation is similar. This is the relation. Now you'll have to tell if T1 is related to T2 or T1 is related to T3 or T2 to T3, right? You'll have to check. How will you check? This is the condition. If I have to prove the triangles are similar, then the ratio of corresponding sides should be same. That is, now let me take ratio of T1. Ratio of T1. What are the sides? 3, 4, 5. 3, 4, 5. So how do I write this in the form of ratio? I should write as 3 by 4 and 4 by 5. Right? These two and these two. With that you can form the ratio. So 3 by 4 and 4 by 5. Now what is ratio of second triangle? It is 5, 12 and 13. 5, 12 and 13. Now if you write it in the ratio form, this and this. So 5 by 12 and 12 by 13. Now I'll write ratio of triangle 3. What are the sides? 6, 8, 10. 6, 8, 10. Now let me write in the ratio form. So it will be 6 by 8, these two and these two. 6 by 8 and 8 by 10. Now how do we know if all these ratios are same? So you cancel this. So 3, 2 3s are, 2 4s are, 2 4s are, 2 5s are. Here can you cancel anything? No. Here also you can't cancel. 5 by 12? No. 12 by 13? No. Right? But here you can cancel. Now after cancelling, if you get same ratios, then it is called as similar. So you have 3 by 4 here and 3 by 4. 4 by 5 and 4 by 5. Therefore, triangle T1 and triangle T3 are similar. So we'll say T1 and T3 are related. T1 and T3 are related. Now let's go to the next problem. Let L be the set of all lines in XY plane, right? L is set of all lines, right? All lines of different lengths. Right? So L is set of all lines, right? It will be infinite. Now, what is relation? R is given as L1 is parallel to L2, right? So R will have pairs of lines. Suppose this is L1, this is L2, this is L3, L4, L5 and so on. The relation between the two lines should be that the lines should be parallel to each other. Now, if I have line like this, these two lines, I can call this parallel, right? This is parallel. Such kind of lines, suppose this is L4 and L5, right? So I'll have L4 and L5 here. And say another pair I will take. This is L6 and L7. L6 is parallel to L7. So I can write L6, L7. So this is just an example. You will have infinite combinations like this. So now I have to prove that this relation is equivalence. So it should be reflexive, symmetric and transitive. Only then I can say that the relation is equivalence. So let's first look at reflexive. So what is the condition for reflexive? For all element A belonging to set A, AA should belong to R. That means here instead of A, I'll put L1. Some line L1. L1, L1 should belong to R. Now what is the relationship here? It should be parallel. Can I say L1 is parallel to itself? Right? Every line is parallel to itself. Since every line is parallel to itself, you can say L1, L1 belongs to R. So you can say R is reflexive as L1 is parallel to L1. Now we look at symmetric. What is the condition for symmetric? If AB belongs to R, implies that BA belongs to R. So now in this case, let's take two lines L1 and L2. If L1, L2 belongs to R, this should imply that L2, L1 should belong to R. Now, if I say L1 is parallel to L2, right? So if I have L1 and L2, this is L1, this is L2. If this is parallel to this line, can I say L2 is parallel to L1? If L1 is parallel to L2, I can say L2 is parallel to L1. It does not matter if I put L1 first or L2 first, but both are parallel to each other. So if L1 is parallel to L2, implies that L2 is parallel to L1. So I'll say R is symmetric as L1 is parallel to L2 implies that L2 is parallel to L1. Now next one, we'll go to transitive. So what is the condition for transitive? If AB belongs to R and BC belongs to R, then this should imply that A comma C belongs to R, right? So now in this particular example, we'll say L1, L2, L2, L3. For us to say that the lines are transitive, we'll have to take three lines, L1, L2 and L3, right? So we'll put in this combination, L1, L2 belongs to R, L2 and L3 belongs to R. This implies that L1, L3 belongs to R, right? So the first time, the fourth element. So L1 and L3 belongs to R. Now here, first thing is, let's take a third line, which is L3. Now if I say L1 is parallel to L2 and L2 is parallel to L3, can I say L1 and L3 are parallel? Obviously, right? If this is parallel to this and this is parallel to this, then all three are parallel to each other, which means that L1 and L3 is also parallel to each other. So I should write this as R is transitive as L1 is parallel to L2 and L2 is parallel to L3 implies that L1 is parallel to L3. Now, since the relation is symmetric, transitive and reflexive, we can say that it is equivalence relation. Now let's look at the second part of the question. Find the set of all lines related to the line y is equal to 2x plus 4. So you have to find the set of all lines that is related to this particular line. This is nothing but equation of a line. Y is equal to 2x plus 4 is equation of a line. So general equation, the general equation of any line is y is equal to mx plus c. This is the general equation. This is the y coordinate, this is the x coordinate, m is the slope, right? M is the slope and c is some constant, any number. Now you'll have to find all lines that are parallel to this particular line. That line is represented as an equation, right? And that equation is y is equal to 2x plus 4. So you should find all parallel lines to this particular line. So how do you denote the set of those lines? So you could have multiple lines which are parallel to this, right? So now say you have line L1. This is line L1. This is represented using an equation and that equation is 2x plus 4. Now I need to find all lines that are parallel to this. So there could be infinite number of lines which are parallel to this. Now, what is the equation of those lines? So the equation of those lines we can say is y is equal to 2x plus c. So just replace this number 4 with c. C is any number, right? Any number which you call it as constant. So instead of 4 you could have 5 or 6 or 7. So generically we'll put c as a number, c as a constant. So we'll say lines related to y is equal to 2x plus 4 are lines having equation as y is equal to 2x plus c. That's all. Now we look at our next problem. Let R be the relation in the set 1, 2, 3, 4 given by, so this is the list of ordered pairs in R. R is nothing but relation. Choose the correct answer. For reflexive, first thing is you should have all similar elements. You should have 1, 1, 2, 2, 3, 3, 4, 4 because there are 4 letters here. So you have 1, 1, you have 2, 2, you have 3, 3 and you have 4, 4. Therefore you can say it is reflexive, right? It is reflexive. Now let's check if it is symmetric. Symmetric is all the reverse combination should be there. So 1, 2, you should have 2, 1. No, you don't have. So right away you can say it is not symmetric. Now let's see if it is transitive. For transitive, let's look at common elements. Here 2 and 2 are common. And if 2 and 2 are common, then the third pair should be 1 comma 2. Right? 1 comma 2. This itself is 1 comma 2. So one condition is satisfied. Like this, you'll have to look at all the combinations. Now, where are the similar elements? So this 1 is repeating, right? You have 1 and 1 comma 3. 1 and 1 is repeating here. So we'll have to look at these pairs. So what should be the third pair? Third pair should be 1 and 3. 1 comma 3. Is 1 comma 3 here? Yeah, 1 comma 3 is here. So this is also satisfied. Now let's look at any other repeated elements. You have 3 comma 3 here and 1 comma 3. Again repeated elements. 1 comma 3 and 3 comma 3. Now, so 3 and 3 is repeated here. So what is the combination? 1 comma 3. Is 1 comma 3 here? It's here. Right? We have another combination 3 comma 2 and 2 comma 2. 2 and 2 is repeated. So we should take this combination and check. So what is the third ordered pair? It should be 3 comma 2. Do we have 3 comma 2 here? Yes, 3 comma 2 is here. So I think we have checked all the combinations, right? So this is transitive. Now we'll see it is reflexive and transitive. Option is B. R is reflexive and transitive but not symmetric. Let's go to the next problem. Let R be the relation in the set N given by A is equal to B minus 2 and B is greater than 6. Choose the correct answer. So now B is greater than 6. B is the second element here, right? So you have A comma B and B is the second element and B is greater than 6. Greater than 6 means 7, 8, 9 and so on, right? Now we should have an ordered pair where you have 7 or 8 or 9. So you have 3 combinations here. You have 3 combinations here. This one, and this one. So this is ruled out because it's not greater than 6. So it's one of these options, B, C, D. Now, how do we verify which is the right one? There's another condition we'll have to check. A is equal to B minus 2. A is equal to B minus 2. Now we have 7, 8 here. We have 2 combinations here. 7, 8 and 8. 7 and 8. So if I take B as 7, I'll get A as 5. If I take B as 8, I'll get A as 6. So A should be either 5 or 6. I don't have 5. A is not 5 here. A is 6 here, right? So this is the only valid combination. So this is the answer. 6, 8, C. So with this, we've come to the end of this particular topic. If you like this video, do press a like and share it. Thank you.